Hello, Pirates. Today we'll be looking at the vitamin C lab. As you see, the purpose of this lab to identify the active ingredient of a common tablet of vitamin C. The common ingredient, ascorbic acid. Okay, here's its formula. That will definitely come in handy in the future. A little foreshadowing for you. Water soluble. It's not stored in the body for long-term use. There are fat-soluble vitamins. There are water-soluble vitamins. Vitamin C is water-soluble. You can take as much of it as you want. If you take excess, your body just excretes it, and it's gone. So what we're going to do is we're going to titrate this, and we're going to see how much active ingredient is actually in a tablet of vitamin C. We're going to see if it matches the label that's on there. So your procedures here, we're going to walk through that. You have 0.1 molar sodium hydroxide, NaOH. You have one vitamin C tablet, approximately, roughly 50 milliliters of water. It does not have to be exact. This is simply to dissolve the tablet and to give you some volume to see the titration in. So this does not have to be exact, meaning you do not need to use a graduated cylinder to measure that water out. 3 drops or more of phenolphthalein, probably more just like a squirt, like a dropper bottle squirt worth of it. And again, I'm going to walk through these next steps for you. Here is your data table. Okay, we're going to talk about the turbo titration, the approximation of how much you put in. Again, you run a turbo titration just to get a ballpark, to get an estimate, to get a rough idea of how much is going to be in there. The next trial you do, trials 1, 2, 3, you would start close to the amount that you put in the turbo titration and then do a slow, accurate, drip by drip titration to get the accurate finish. We're going to look for an initial. We're going to look for a final. The important part is we're looking for a total amount of NaOH added. Okay, we're going to get those totals. We'll talk about how to calculate that down the road, but now let's take a look at the procedure. Hopefully you enjoyed the lab, Pirates. Now let's do some calculations. So first off, we're going to use this. We're going to use 28.4 milliliters as our average amount of NaOH titrated in. Okay, so let's head down to this page here. We have a couple things we need in our data table. We have our molarity of NaOH, which is 0.1 molar. Molar mass of exorbic acid is 176 grams per mole. Now, if you're unaware, C is you have 6 of them. Hydrogen, you have 8 of them. Oxygen, you have 6 of them. Carbon's molar mass is 12. Hydrogen's molar mass is 1. Oxygen's molar mass is 16. I would multiply those, and then I would add all those products together, and that would give me 176. Again, we used 28.4. That's the data we're going to run here. And then you're given a couple constants here, nothing that you can't find on your mole map. But the whole point of this lab, calculate the number of milligrams of exorbic acid in the tablet of vitamin C. So if I was to reference my mole map, oh, I apologize for the mess. If I reference the mole map here, if we're looking for milligrams, okay, we have to look at what we have about exorbic acid. And we really don't actually have much. What we have a lot of information on is information on NaOH. Okay, so what we're going to have to do, because we don't really, if we're going here, we don't really have a starting point for exorbic acid. Now, what we can do is say, if we can calculate the number of moles of NaOH used, that's equal to, in this lab, this will change in the future. In this lab, the moles of NaOH are equal to the moles of exorbic acid, C6H8O6. So we actually have to find the moles of NaOH first, and then we can calculate how many milligrams of exorbic acid we have. Okay, that is the whole point of a titration. The titration endpoint is reached when your moles are equal. So we have a lot of information. If we look at a really rough picture here, here's our Erlenmeyer. Oop. I'm very good at art. Come on. Here's our Erlenmeyer. This is our NaOH. This is our vitamin C, our exorbic acid. We know a lot about this. What we can do is we can find out how many moles of NaOH we added into the exorbic acid, and then we know those two numbers are equal. So let's do that. Let's take, and here's some structures for you. So we are going to go from milliliters to liters to moles. This is all NaOH information. And then we're going to go from moles to grams to milligrams. And this is all the vitamin C information, exorbic acid. Again, where am I getting that from? I'm looking here. I'm realizing that I can go from milliliters of NaOH to liters to moles. We're kind of glancing over this part right here. We're just calling these two equal, because again, this is moles of NaOH. We're going to set them equal to moles of vitamin C, exorbic acid. And then we're simply going to go from moles to grams, grams to milligrams, and this is milligrams of vitamin C, again, also exorbic acid, C6H8O6. Okay, so here's my big picture of what we're doing. Again, this portion here will change in the future, but right now we're saying it's, for those of you who need to know, it's a 1-to-1 ratio, mathematically, We're just saying that the moles are equal. Okay. So let's go ahead and do that. Let's start with, I'm going to shrink this up, all of this just a little bit to give me some room. Magic. All right, we have 28.4 milliliters NaOH. I put a little placeholder. I'm going to use all of my equalities as I go through. Again, where I'm getting these equalities from, I'm going to use this equality here, this equality here. Taking note that I know the Taking note that I know the molarity of my NaOH, which gives me the moles in 1 liter. So back to this. Times 1 liter, or 1,000 milliliters. Cancel those milliliters. And then times 0.1 mole over 1 liter. And again, I got that 0.1 mole from here. Okay. So I can continue this and I can run it in one long equation, or I can break it down, which I'm going to do just to simplify it a little bit. Times 0.1, I got my calculator here, and then divide that by 1,000. So I get 0.00284 moles of NaOH. Well, I'm telling you that those numbers are equal to the moles, 0.00284 moles of C6H8O6. We're setting them equal to each other. Okay? Let's use some little magic here and give me some more room that I need. So I'm now going to go from 0.00284 moles of acid. I'm going to multiply that by my molar mass, 176 grams of vitamin C. You can put C6H8O6. I'm just putting vitamin C to save some time. Didn't save a lot of time because I talked about it anyway. And then I'm going to cancel the moles, 1 mole. And then I'm going to go to milligrams over 1 gram. I can pull this up and show you the math as I do it. I'm going to multiply across the top, 0.00284 times 176 times 1,000, and I get 499.84 milligrams of vitamin C. And if you were to look at the bottle, you'll see that they are 500 milligram tablets of vitamin C. So that's fairly accurate. It's what we're looking for. Your teacher may go on to percent error. You may go on to looking at how much of that pill is other substances. But our goal, I'll span this out, and I know it's a lot of stuff. If you're applying this to other labs, please pause this lab, rewind it, plug in your data, and then you should be able to come to the conclusion of how many, calculating the number of milligrams of ascorbic acid, again, knowing information about NaOH, setting that equal to the information of vitamin C, setting the moles equal, and then calculating. Hope you like the lab.